Section 5.5, integration by substitution. These are the objective of this section. By the end of this section, you should be able to find, indefinite and definite integrals using substitution method. Let's start with indefinite integrals.
Of finding indefinite integrals. So that means you need to find the integration of any function f of x, and sometime problem they look very complicated, but by using the substitution method we can change the problem into a simple looking type of problem. For example, here the substitution rules. Let's say you have a function and then it's a composition of two different functions and there is a derivative of inner function. Then you can always replace that inner function by u and change the problem into like this. Okay, and that idea of substitution uh, helps us to solve the integration problem. So what do? First of all, find out a right function to substitute for, and then find the derivative of that function, and then all the variable x, change that into the variable of new substitution, like here in this case it's u, and then after that find the integration. Some of the standard integration for trigonometric functions are here, like integration of tangent of x is ln absolute value of secant of x, and then all of this you have to know this integration of trigonometric function as well. Let's look at some examples. For example, here, to find out the integration of this problem, first of all try to substitute for the function you have given, but make sure that whenever you do the substitution, the derivative of that substitution should be available here. In this case, I'm going to substitute this inner function here by u. So let's say u equal 4s minus 9. Now I need to find the derivative of u, which is du equal derivative of on the right side, which is derivative of s with respect to s is 1, so that would be 4. So we are trying to find the derivative with respect to s both sides. But now instead of du over ds, we can also write it down as a du equal 4 times ds. So we go back here in this problem and we're going to replace this value of u here. By doing that, you will be able to see 1 over u to the power half. The square root means power half, and this ds can be replaced by this value. If you solve this, ds is equal to du over 4. So we have to change that ds in terms of du. So that is du over 4. Now I can bring this 4 outside, so that will be 1 over 4 u to the power half. I'm just bringing this u to the top by changing the sign of this exponent du. So finding the integration of this is equivalent to finding the integration of this. Now for finding the integration of u to the power negative half, we can use the power rule for the integration, which is negative half plus 1 over negative half plus 1. Since this is indefinite integration, so you need plus c constant. Now just do the simplification here. 1 over 4, this is u to the power half, and then again if you add negative half and then 1, that will be 1 half. So you need to simplify that. This 1 half goes to 2 over 4, this 2 goes to up, if you flip it, and then this is u to the power half plus c. Eventually this is 1 half. We need to plug the value of u back from here. So u is actually 4s minus 9, and there is a power half plus c. So that will be our final answer. So we use the substitution to change the problem from complicated looking problem to simple looking problem, where we can use the formula of integration directly. But eventually we need to find our answer in terms of the original variable. In this case it's a s. Look at here, this is a new problem. Here there are two functions, as you can see, tangent and secant. So you need to substitute for one of the function, but make sure that when you do the substitution, derivative of that function should be available here. In this case, we can substitute for tangent. So let's say u equal tan of x. By doing that, what happens is we can say du, if you find the derivative of tangent of x with respect to x, it will be secant square of x. So that means the du can be replaced by or secant square x dx, meaning the secant square x dx, as you can see that is available here. I can replace this by du. So after that, I can change this problem. Tangent is u, so I can write it down as a u to the power 6, and secant square x dx can be replaced by du from here. So now finding the integration of this problem is equivalent to the finding the integration of u to the power 6 with respect to u. So we can use the power rule of integration, which is 6 plus 1 over 6 plus 1, and then because it's an indefinite integral, so we need plus c. So this is u to the power 7 over 7 plus c. But finally we need answer in terms of x, so we're going to plug the value of u from here, which is 10 to the power 7 over 7 plus c, and that is our final answer. One more example. So make sure that whenever you do the substitution, that substitution should change this problem into simple looking problem. So in this case, whenever you have exponential function and trigonometric function, do the substitution for the exponent here. So if you substitute u equal negative cosine x, that will help us finding the derivative, which is the derivative of cosine is negative sine, and this negative and that negative becomes positive sine x. So that means du can be, this sine x dx can be replaced by du. So you can see that this sine x and dx is already available here. So this problem now becomes e to the power u du. So this is a simple integration problem. The integration of exponential function e to the power u with respect to u is actually e to the power u itself plus c. Plus c means it's because of indefinite integral. So e to the power u, we need to replace the value of u using this value, which is negative cosine of x plus c. So that is our final answer. So this is initial value problem, meaning after finding the integration, the indefinite integration, it gives you constant, but because of this initial condition, we can use that initial condition to solve for that constant. So for finding the s, if you just integrate, s is integration of ds over dt with respect to t. Okay, that is the relation. So ds over dt is given here, which is 28t times 7t square minus 5 cube. So we need to find out the integration of this complicated looking problem, but we can change this problem into simple looking by using the substitution for appropriate function. In this case, we need to substitute for this function, which is inside the parenthesis. So let's say u equal that 7t square minus 5, and don't forget that there is a dt. And now if you find the derivative with respect to t both sides, it will be 7 times 2 is 14t. Okay, so I can just replace this 14t dt by du. But here, if you look at here, you can see 28t dt. So instead of 28, I can write it down 2 times 14. So 14t dt can be replaced by du. So what I'm going to do is I'm going to write it down this as a 2 times 14t dt can be replaced by du, and this thing can be replaced by u to the power 3 du. So look at here, du means 14t dt times 2 is 28. Okay, so now this is very simple problem because I can bring this 2 outside and I can find out the integration of u cube. That would be u to the power 3 plus 1 over 3 plus 1 by using the power rule of integration. So that is 2 over 4, which is 1 over 2, u to the power 4. But remember, u is 7t square minus 5, so this is 7t square minus 5 power 4 plus constant. So that is the value of s of t. That's s. That is the value of the function. But Because we have given the value of the function at 1, so we need to find out the value of the constant. That's called initial value problem. Finally, we don't want our answer in terms of c. So what do we do? Just replace t by 1 and solve for c. By doing that, s of 1, which is actually 14, that's given here, is equal to, if you replace t here on the right side, that will be half times 7 times t square, which is 1 square, minus 5 to the power 4 plus c. Okay. Okay, so 7 minus 5 is 2, so 14 equal half times 2 to the power 4 is 16 plus c. So 2 times 8 is 16. So if you solve for c by subtracting 8 from both sides, so you get c equals 6. So eventually, what is the answer? The answer would be, I'm going to go back here. I'm going to use this thing. The answer, s of t, is everything, copy everything and just plug the value of c, which is 6. Half 7 t square minus 5 to the power 4 plus 6. So that is our answer. So remember, whenever you try to solve initial value problem, you need to find out the value of this constant. You cannot write down your answer in terms of c. You need to find out the value of constant by using that condition. Okay.
Definite integrals using substitution.
So if we have to find out the definite integral sometime, changing problem into another form might be helpful. So as you can see that on the left side, it looks a little bit complicated, but after doing substitution for this function g of x as a new variable u, we can change this problem to simple looking problem. And then after that, we can use the fundamental theorem of calculus for finding the definite integral, and we can solve the problem. Before we do actual example, let's look at the two finding here. Let's say if we have to find out the integration of even function, so this is the graph of even function, the first one, and we are trying to find out the integration from negative a to positive a, where a is the same number. Then the value, the area, or the integration to the left side of 0 and to the right side of the 0, this would be equal. As you can see that they have the equal area. And if we are playing with the odd function from negative a to positive a, the integration to the right side and integration to the left side, because integration means it's a area if it's above the x-axis, and it's a negative of area if it's below the x-axis. So since they have same area but opposite sign, so while finding the integration, that will be cancelled out. This portion and this portion will be cancelled out. So we can conclude that finding here, if we have continuous symmetrical function and if the function is even function, finding the integration from negative a to positive a is equal to 2 times finding the integration from 0 to a. Similarly, if we are playing with the odd function, finding the integration from negative a to positive a is actually 0. So now let's look at some example using substitution method. The first example is, we want to find out integration of this problem, and we would like to substitute, so that substitute for a function here, so that problem will be a little bit simpler looking function. So what I'm going to do is, because as it is finding the integration, because of this radical sign and because of this t outside, it's not easy. So what I'm going to do is, I'm going to substitute u equal, let's say u equal 4 plus 5t, and then I'm going to find out the derivative on both sides. So I'm going to find out du, which will give me 5 times dt. So substitution means everything in term of t will go in term of u, this dt will go to du. So I want to find out the value of dt, which will be du over 5. Okay, and similarly we also have to change this limit of integration, like from a to b, it goes to the value of the function at a and the value of the function of at b for that new substitution. So as you can see here, when t is 0, u would be 4 plus 5 times 0, which is 4. When t is 0, that will give us the value of new variable as a 4. And when t is 1, that will give us the value of new variable as a 4 plus 5 times 1, which is 9. So this integration after this substitution becomes 4 to 9, and then instead of t, we can find out the value of t by simplifying this expression, which is, I'm going to do it here, u minus 4 equal 5t, and we would like to find out the t. So t equal u minus 4 over 5. So I can replace this t by u minus 4 over 5, and I can replace this square root of 4 plus 5t as a square root of u, and I can replace this dt by du over 5. So I can keep this constant 5 times 5 outside, which is 1 over 25, and inside we will have 4 to 9 u minus 4 times u to the power half. If you distribute this u here, it will give me u to the power 3 over 2 minus 4 times u to the power half du. So this is the integration now we need to find out. And finding this integration is easy because we just need to use power rule. Okay, so it will be 1 over 25. If we use the power rule for the first one, it will be u to the power 5 over 2 divided by 5 over 2. So it will be 5 over 2 divided by 5 over 2. And for the second one, 4 times u to the power half plus 1, which is 3 over 2 divided by 3 over 2. And then limit of integration is from 4 to 9. So if we use the fundamental theorem of calculus, now we need to put u equal 9 for the first time minus u equal 4 next time and do the calculation. We have to use this 5 over 2 as a 2 over 5, this 3 over 2 as a 2 over 3. Okay, just simplified form, just do the simplification. If we do that, okay, if we do that, finally I don't have the space here, so I'm going to put that value. So I'm going to flip this 2 over 5 and 3 over 5. So okay, so I'm going to just keep continue that thing. From here it will be 1 over 25, and that will be 2 over 5 u to the power 5 over 2 minus 4 times 2 over 3 u to the power 3 over 2, and then there is a 4 to 9. Now we need to put u equal 9 here first. That will give us 2 over 5 times 9 to the power 5 over 2, which is actually 3 to the power 5 minus 8 over 3 9 to the power 3 over 2 minus, if you remember the integration of the finite integral, uh, let's say from a to b is f of b minus f of a using fundamental theorem of calculus. This f is antiderivative of a small f. So negative f of a means the value of this thing at 4, which will be 2 over 5 4 to the power 3 over 2, and this negative and this negative becomes positive 8 over 3 4 to the power 3 over 2. Now we just need to simplify this expression. uh, Before that, don't forget that this means 9 to the power 5 over 2 means it's a 3 to the power 5, because 9 means 3 squared. So I can write it down this as a 3 to the power 5. Same thing here, I can write it down as a 3 to the power 3 minus 2 over 5. This is square root of 4, which is 2 to the power 3. 2 to the power 3. This is again square root of 4, which is 2 to the power 3. Okay, now we do the simple calculation here. Just use your calculator, and then eventually you are going to get 506 divided by 375. That's the value. Let's look at another problem just by using the substitution method one more time. Here it looks complicated, so we're going to substitute for this denominator function. So let's say u equal 7 minus cosine cosine 40, 7 minus cosine 40. So if I substitute for the top one, it will not reduce my problem, so we need to substitute for the bottom one. And now find out the du, which is the derivative of cosine 40. Derivative of 7 is 0, minus the derivative of cosine 40 is minus sine 4 times t times 4 times dt. So that is actually 4 times sine 40 dt. Okay, so I can replace this top part 4, 4 times sine 40 dt by du. Okay, and now we have to replace this limit of integration. So when t is 0, by plugging t equals 0 here, it will give me 7 minus cosine 0, which is 1, which is 6. And when t is pi over 4, I'm going to replace this t by pi over 4, which is 7 minus cosine pi, which is 7 minus minus 1, which is eventually u equal 8. So by using this substitution thing here, this problem will now change from 6 to 8. On the top part I can write it down just u, on the bottom part it's just u. So integration of 1 over u is actually ln of absolute value of u, but this u is positive, so we don't have to use the absolute value. And now by using the fundamental theorem, this is ln of 8 minus ln of 6, and if I use the property of ln function, it's 8 over 6, so eventually it's a 4 over 3. So that's the exact answer. Okay, we would like to find the area of this shaded region here by finding the integration. So we know this region is below the x-axis. So if we find the integration of this thing from negative pi, which is coming from here, and it's going up to 0 of this function, which is 3 times sine x square root of 1 plus cosine x dx. If we find the integration of this, it will be the negative of the area. So the area will be actually the absolute value of this integration. Absolute value means if it's negative, make it positive. So our goal is to find the integration of this part, which we can do by using the substitution method. So we are going to substitute for this inner function 1 plus cosine x, and by doing that, we can change the problem. So let's say u equal 1 plus cosine x, then du would be the derivative of 1 is 0, the derivative of cosine x is negative sine x dx. Okay, and when x is negative pi, by plugging x equal to negative pi here, the u would be 0 because 1 and then cosine pi is actually negative 1, so 1 minus 1 is 0. When x is 0, that means 1 plus cosine 0, which is 1 plus 1 is 2. So this integration whatever we're trying to find, that will be changed to 0 to 2 and then 3 sine x. As you can see that sine x dx can be replaced by negative of du, so I can just bring that negative sign outside, so it will be 3 du, and then for this one it's a square root of u du. So I can replace this problem into 3 square root of u du. This negative sign, it doesn't matter because of this absolute value, it will be eventually be positive. So now let's find out the integration of u to the power half, which is by using the power rule, it would be 3 half over 3 half, and then we have to put the limit of integration from 0 to 2. This 3 and this 3 is gone, so this 2 comes to the top, and then after using that fundamental theorem, I have to replace this u by 2 minus this u by 0, so that's 0. So eventually it is 2 to the power, it's a 1 power, it's a 3 over 2 power, so eventually it will be 5 over 2 power. So that's the area. Because there is no negative sign, we can say that that's the area of this part. And that negative sign went off. You can see that this negative sign is just gone because of this absolute value. Okay.